A 3.8 billion parameter model just scored 94.6% on Math 500. It beats reasoning models twice its size, and it runs on a laptop with about 5 GB of memory. And also it's completely free under an MIT license. Small language models stopped being toys sometime in the last year, and almost nobody updated their assumptions. By the end of this video, you will know exactly which model to run on your machine, whether you have an 8 GB laptop or a 24 GB GPU, and why the smartest AI teams are quietly switching to them. Here is a strange part. There is no official size cutoff anymore. The old rule was anything under 7 billion parameters was small model. Today, the list of so-called small models runs from 125 million parameters all the way up to 30 billion. Why? Because the real definition changed from parameter count to deployment profile. A 30 billion parameter mixture of experts model that only activates 3 billion parameters per token behaves like a small model where it matters: memory, speed, and cost. If it fits on one consumer GPU and answers fast, it is small. That single idea explains almost everything on this list. The economics are brutal. Nvidia research measured that serving a 7 billion parameter model is 10 to 30 times cheaper than serving a 70 to 175 billion parameter one, counting latency, compute, and energy. On top of that, a local model has zero network round trip, so responses start instantly. Your data never leaves the machine, so there is nothing to breach on a server, and it keeps working on a plane, in a basement, or when the API is down. None of this matters if small models are dumb. The rest of this video is the evidence that they are not. If you want one general model, start with Qwen3. The small end of the family runs from 0.6 to 8 billion parameters, speaks 119 languages, and has a switchable thinking mode for hard problems. The 4 billion version rivals Qwen 2.5 72 billion, a model 18 times larger from one generation earlier, and it needs only about 2.5 GB in 4-bit. Google's answer is Gemma. The 12 billion version handles text, images, audio, and video on a single consumer GPU, and the quantization-aware build cuts memory by roughly 72%, down to about 7 GB. Both are Apache 2.0, free for commercial use. That model from the cold open is Microsoft's 5.4 mini reasoning, 3.8 billion parameters, trained specifically for step-by-step math. On AIME 2024, it scores 57.5%, where its own base model scored 10. On Math 500, it hits 94.6%, and on GPQA Diamond 52%. It beats DeepSeek R1 distills at the 7 and 8 billion scale. The catch is focus. This is a math and logic specialist, not a general chat model. But if your workload is reasoning heavy, nothing this size touches it. And the MIT license means you can ship it in a product. Click pause. If this is useful, please do subscribe. Now the coding pick. Cohere's North Mini code is 30 billion total, 3 billion active MOE built for agent coding, reading whole repositories, editing files, running tools. It has a 256K context window, and on the artificial analysis coding index, it scores 33.4, beating Devstral Small 2, a dense 24 billion model. In 4-bit quantization, it takes about 17 GB, which means repo level coding agents now fit on a single RTX 4090 and Apache 2.0 again. Nvidia's Nemotron 3 Nano is the clearest proof that deployment profile beats parameter count. 30 billion parameters total, but a hybrid Mamba and transformer design with 128 experts, of which 5 fire per token, so only about 3.2 billion parameters are active. The headline feature is context, up to 1 million tokens. That is an entire code base or a stack of contracts in one prompt on one 24 GB card at 4-bit quantization. There is also an Omni variant that adds image, video, and audio understanding. The license is NVIDIA's open model license and commercial use is allowed. IBM's Granite 4.1 is the counter argument to the whole mixture of experts trend. The 8 billion dense version beats IBM's own previous 32 billion mixture of experts on function coding. 68.3 versus 64.7 on BFCL V3 scores 92.5 on GSM 8K math and handles up to 512K tokens of context. It was trained on around 15 trillion tokens and the 8B fits in about 5 GB at 4-bit. For enterprise style work, tool calling, extraction and long documents, it is the most boring and most dependable pick here. Apache 2.0, again no strings. Two more worth knowing. Hugging Face's small LM3 is 3 billion parameters and the most transparent model on this list. Weights, data mixture and training configs are all published. Mistral's Mistral 3 family at 3, 8 and 14 billion ships base, instruct and reasoning variants with Vision, all Apache 2.0. Now the trap. Kohei's Tiny AI covers over 70 languages at 3.35 billion parameters, but it is licensed non-commercial. Read the license before you build. Small does not always mean free to ship. And we have seen that two models, one is open and one is restricted. So always check before you choose one. So here is the cheat sheet by hardware. An 8 GB laptop, then Qwen3 4 billion for general use, and use 5 for mini reasoning for math. Now if you have a 12 to 16 GB machine, Gemma for 12 billion for multimodal, and then Granite 4.18 billion for tools and long documents. A 24 GB GPU, Nemotron 3 Nano for huge context, North Mini Code for coding agents, and this is where the field is heading. NVIDIA's researchers argue that most agent calls are narrow and repetitive tasks, exactly what specialist small models are built for, with big models reserved for the rare hard query. So small models in 2026 defined by what they run on, not how big they are. Qwen3 and Gemma 4 for everything, 5 for mini for reasoning, North Mini Code for code, and Nemotron Nano from NVIDIA for a million token context, and Granite for dependable enterprise work. Make sure you always check the license so that it's not gated for your commercial use. Every model listed here runs on hardware you might already own, and every benchmark I quoted comes from the model cards and papers linked below. If you want to actually set one of these up locally, the next video walks through it end to end. Subscribe so you do not miss it, and I will see you in the next one.